In the spring of 2017, my dad told me about Talia Duff. She lives in Ipswich and has a rare disease, CMT4J, which causes rapid muscle loss similar to ALS. In the past year, she has gone from using a walker to using a wheelchair full-time. So I pulled my robotics friends together so we might invent a device to help Talia live more independently. Last year, I led my friends on my first robotics team through a project with Ocean Alliance, a very cool, non-invasive whale research organization that collects genetic material by flying drones through whale snot. We developed Snotlock, a device to improve the drone's flight accuracy. Our work was featured on WBZ News, Reddit, and across the World Wide Web. In July, funded by a grant from the Payne Foundation, we hosted the project's first meeting to begin Phase 1 with planning, research, and development. We call it Team Talia, or Project Deltoid. The meeting served as a way for everyone to meet each other, and for the team to start working. We began our preparation and set up a 4-phase plan.
October 8th.
Design meetings began immediately. We only had a few weeks to put together a prototype. Several designs were considered, knowing we had to choose one at a time to make progress. Part of the grant was to go towards public relations, to bring awareness to the disease. I'm Roman, the project manager. I began the venture as a high school senior and am now a freshman at Sarah Lawrence College. Philippe, a senior at Ipswich High School, is one of the programmers and designers, and is currently the captain of the first robotics team. Volunteer and mentor Alan Radcliffe works professionally as a mechanical engineer.
The prototype is going to entail, at the end of the phase...
By the next meeting, the parts had come in. Research led us to work on a wearable device, an electromyography sensor to detect small movements, and an accompanying microprocessor. First, we needed to assemble the devices.
What types of boards are you hooking up?
Right now, we are taking our myoelectric action potential sensor. So this is basically what the actual electrodes will be attached to. When you tell your bicep to move, that electrical signal is what this will pick up.
The next step was programming the assembly. Annabelle Platt, a high school junior and designer on the team, explains.
So for right now, we're just trying to get the Myo's electric sensors working. So just for our initial test, we're going to have it read the analog value from the sensor. We're going to get a value when...
By midsummer, mentor Alan Radcliffe had moved to New York, but remains committed to the project, leading and attending meetings over Skype, allowing us all to learn to work remotely.
Yeah, there's adhesive to you.
Yes.
Have you tried different positions?
Yes.
How did they work?
This is the most stable one we found.
Do they look like they have different values for front and side?
Just a little bit of interference.
Yep. Well, that's basically all.
By mid-August, we had an initial design concept for the prosthetic device. Phase 1 of the project was complete. Our group had set out to make initial design progress on the prosthetic assistive device, to detect muscle movement, and to support and assist that movement. To accomplish this, we attached a myography or muscle sensor to the body, then connected the sensor to a microprocessor, and finally connected that to a motor. We could detect muscle movement, and with some programming, drive a motor. The building blocks for an assistive device for Talia. Onward and upward, we keep going. Phase 2 goals are complex. We will advance the prototype and create a website that serves as a working hub for a remote team of students and adults, while we make videos like this one. We hope our work helps Talia. Her mother, Jocelyn, is working independently to fund a clinical trial to make way for genetic therapy, which may cure Talia's rare disease. Her 2017 goal is $1 million. Remember to subscribe, like us on Facebook, and go to Cure CMT4J to make a small donation. Every little bit helps. Thanks for watching. See you next time.